All right, I'm going to get started then. Welcome to Club A. My name is Keith. I'm the president of the club. My experience has been playing Capture the Flags for the last 2 years and also completing most of the information and system security course stream at McEwen University. If you'd like to check out our club, check us out at cluba.ca. There you'll find links to our Discord and YouTube channel. So if you were with us in person a couple weeks ago, we talked about what are capture the flags. And so tonight we're going to be starting by looking at the different skill categories that you can use in capture the flags that also have a overlap with cybersecurity. So the skill categories in capture the flags kind of overlap with cybersecurity, although a lot of the times capture the flags will not be a one-to-one correspondence to something that you would be looking at in the field of cybersecurity. It is a good place to get started and learn the tools. And so that's basically what these presentations are aimed at doing, is helping people get introduced to the tools and doing some capture the flag style challenges. So tonight we're going to be looking at the skill categories in bold. We're going to be looking at open source intelligence and network traffic analysis. Under open source intelligence, there's several categories that are all kind of grouped together. And yeah, we'll get into that tonight. So starting with open source intelligence. Open source intelligence is any information that's available freely through the internet or through public sources, such as libraries, posters, maps, charts, infrastructure records, professors, social media, billboards, etc., etc. Anything that you can access freely can be considered open source intelligence. There's many tools available to approach problems in capture the flags that present you with an OSINT style question, and we're going to be going over a couple of them tonight. We have also gone over a couple of them in past presentations, so if you'd like to see those, check out our YouTube channel. One of the biggest open source intelligence tools out there would be a search engine like Google. Google is a very powerful search engine with lots of tools available within it to help you sort and search through information on the internet. If you're interested in cybersecurity or you're pursuing a post-secondary degree, I would assume that you're at least fairly familiar with how Google works and how to use it, and how powerful your search queries can be. Some specific tools related to Google would be the powerful Google Dorks, which are advanced search term operators that you can put into the search bar. We have done a tutorial on Google Dorks in the past, so I'm not going to be going over it too in depth tonight. I would recommend checking out our video from before or stopping in our Discord to ask some questions if you would like to know more. We also have the Google Hacking Database, which is essentially a curated list of Google Dorks that can give you some interesting results. I highly recommend checking it out at exploit-db.com. And then there's also the Google Reverse Image Search. So Google Reverse Image Search can help you find where an image has come from on the internet. So if you're not sure you're not sure about an image, you would be able to put it into the Google search bar here and literally search using an image. So yeah, this is Exploit DB. They've got the Google hacking database as well as the exploit database that has common exploits listed on there. Highly recommend checking out this website. It's a good source of information, and some cool, interesting things are listed on there. And then here's an example of reverse image search. This particular image is from a capture the flag challenge that we've done in the past. And I'm pretty sure the challenge was asking where exactly is this located. Using Google image search made it very easy to find out exactly where this Star Trek Sports Center is. Another really good tool for open source intelligence is called the Wayback Machine. The Wayback Machine is a internet archive. Basically, anyone can save a website onto the Wayback Machine, and it can provide you records for the last like 30 years essentially on the internet. It's pretty interesting being able to go onto the Wayback Machine and see websites from, the 90s and how far we've come, particularly for OSINT challenges and capture the flags. This could be a tool that helps you solve a challenge. Here's a just quick look at how the Wayback Machine works. So if you search for a domain on the Wayback Machine, you'll be presented with this calendar view. There's several different ways that you can sort and search through the results, which are clickable at the top. There's also ways to make more advanced queries on the Wayback Machine. But essentially, what you're seeing here is the calendar way of sorting. So it's going to give you times that the page was archived on the Wayback Machine. So as you can see, nexopia.com, probably the most popular time that this site was around 2005, 2006, right before Facebook came out. This was like a social media site in the mid 2000s, right before Facebook came out, kind of the same time as MySpace. So yeah, you can see that it has archives going all the way back to 2001, and you can click through it and see the website in its state at that particular time. OSINT is such a large category that we're not going to be able to cover even a fraction of the tools available to you. I recommend checking out a website called osintframework.com. OSINTframework.com is going to give you an idea of tools that you can use for different OSINT information. So as you can see the list here, you can search for, it gives you tools to search for usernames, email addresses, domain names, IP addresses, and on and on and on and on. And essentially it is a good starting point for tools for finding information on the internet. It might also give you an idea of, hey, maybe some of my information can be found this way. Might start making you think a little bit more about your privacy. Like I just said, there's so many tools for OSINT that we cannot possibly go over all of them. Here's a quick list of other tools that we thought were good enough to insert into the presentation. We've got the TinEye reverse image search, which is a different reverse image search than the Google one, just in case you don't get the results you need from Google. We've got Forensically, Metadata to Go, Online Barcode Reader, Recon on wireless routers, Hacker Chatter. We've got particular Linux tools that can help you with OSINT challenge as well, like EXIF tool and EXIF. EXIF tool will extract data on photos, such as the type of camera they were taken on, location tags. There's even a comment field in the EXIF section. So it can give you a lot of information about a picture that you're looking at as to where in the world it might have been taken or what kind of device took the picture. Some general tips for capture the flags that employ OSINT challenges would be to make sure that you're clicking around and look for all the details. You might think that you're not on the right track, but it's honestly like a detective mini game. It's how well you can search the internet. You're going to want to look for very distinct features, keep an eye out for the little details to help you solve challenges. Social media can also be a huge help when you're looking at solving OSINT style challenges. So yeah, that's a brief rundown of OSINTs. We've also done OSINT presentations in the past that cover other tools and other techniques. OSINT is a very valuable skill set that will help you to solve challenges and capture the flags, and also keep up to date on information that you might be interested in. Moving on quickly now, we're going to move to scanning and reconnaissance. Now, this falls under pretty much the same category as OSINT. We've participated in Capture the Flags where they separate this, and I think the distinction between Recon and OSINT is that in those particular competitions, they're looking at Recon as Recon on particular computer systems. So when we're talking about Recon, we can talk about two different types. We can talk about active and passive. A passive Recon is any sort of reconnaissance you can do without interacting directly with your target. So like we saw in the OSINT framework, using different tools to get email addresses, employee information, phone numbers, domain names, cell phone IDs, container ships, and project repositories. We've done Capture the Flags in the past where you needed to look up specific container ship tracking numbers, and there's whole websites online that will help you like track container ships in real time, as well as like air traffic. These things are all public knowledge and available for you to look up and browse on your own. Another good place to look for passive recon would be like project repositories on GitHub or GitLab. If you know how a website's code is written, chances are you can find a vector for getting the flag or whatever your goal may be. Active scanning is more probing computer infrastructure using tools like Network Mapper, Directory Buster, Dig, or Shodan. So one warning about active scanning techniques is that you do not want to use active scanning tools on machines if you do not have explicit permission to do so. Okay, we do not condone any sort of activity where you're probing someone else's computer from yours. It can be seen as an attack, and a lot of intrusion detection services will just blow up with flags if you're trying to scan someone's network. If you don't have permission, the consequences can be anywhere from your ISP terminating your connection if they get a complaint, or all the way to legal trouble. There have been cases in the past where simply running Network Mapper on a domain that someone wasn't allowed to, where they ended up in court. So please, please, please do not use active scanning tools on machines if you do not have explicit permission to do so, preferably in writing. With that being said, we've got a nice list of tools here, and I'm just going to post these in the lounge chat afterwards that will help you find some more tools for reconnaissance. And of course, the osintframework.com is also another great place to start. So we're going to just kind of quickly go through Network Mapper. Network Mapper is a loud tool, as in it can be easily detected that you're running Network Mapper against someone else's service. So if you are running it against a domain or IP address that you do not have permission to do so, they're fully within their rights to file a complaint against your IP address where the probing is coming from. It can be seen as an attack. So like I said, do not under any circumstance run Network Mapper against a service or domain that you do not have explicit permission to do so, or that you own yourself. That being said, Network Mapper is a very, very handy tool, especially for internal networks. It can help you determine what ports you have open internally and what is going on your network. So here's a quick example. Just nmap and then the host address will give you a scan. Running it on my local subnet here in this screenshot, we can see, or on a local IP here, we can see that I've got 3 ports open on this particular IP address, and it also gives a report as to what services are running. So this is just the basic Nmap. But we can also do a scan of the same address with a range of ports. So the basic one, as you can see, it doesn't detect the service past 3128. I'm pretty sure it's the first 4,000 ports that Nmap will run, or at least the first 4,000 common ports. Let me know if I'm wrong in the comments or in the lounge chat if you have a question. Speaking of which, we just got a question in the chat. What if I do it from China or some other location? I would never admit to saying that is a good idea. Like I said, do not run active scanning tools against services, domains, or machines that you do not have explicit written permission to do so, or a machine that you own. So yeah, back to this. So the basic Nmap is just going to scan the most common ports. You can define a port range with the -P option. Here I defined 1 to 40,000. And we picked up a port that wasn't shown in the original scan. So we picked up port 8006 on this particular machine. So you can also do all ports with the -P-. That's going to give you all the ports. Beware that this scan is going to take a very, very long time because it's going to scan every port from 1 to 65,000 something. Someone give me the exact answer in the chat there. You can also do CIDR style addressing. So essentially you can scan an entire subnet. So I'm scanning the entire subnet at 10.7.8.0. That's what this command is here, just the basic Nmap command. And as you can see, I have several machines running with open ports running several services. This is just my home network here. You can also do the -A flag, which is going to give you port service and version number, and as well as operating system version number. So this is a very slow scan because it's using several scripts to achieve this. You can also designate the port here. So as you can see, I run the Nmap -A, which stands for aggressive. I thought it stood for attack for the longest time, but it's actually aggressive. And we get back information that is very specific. So we can see what version of OpenSSH is running on port 22. We can see what version of RPC bind is running on port 111. And we can see the operating system down at the bottom of the scan here. So it gives you very particular information, and this can be very useful in a recon situation. In a recon situation, you're going to be looking for something that is vulnerable. You're going to be looking for something that is open for your attack, open for you to get the flag for the CTF competition. So make sure you keep track of your scans, and it's a very good idea, like just for basic capture the flag, throw this scan on the machine that you're looking at, and then do something else, because this scan actually does take a little while to complete. And you can try this yourself on your own network. Later on in the workshop presentation, we'll be giving you a target to try this on. As you can see, it is very, very noisy. Just from running this on my home network, this is just a clip from my Wireshark output, but I think it did something like 6,000 connection attempts, because Nmap is going to try to probe on every single port. So that is very, very loud, and like I said, very easily detectable. Very easy to look at the IP address where this is coming from and block it. Very easy to look at the IP address where this is coming from and call their ISP. It's very easy to detect this type of scan. So Nmap has very, very, very huge functionality, and even scripts to enumerate specific services in its default install. So you can read the manual on Nmap to find out more information. Probably the script that you're going to want to run is the -sc-sv. -sc means it's going to run the default script, and -sv is going to bring up the port version number. So if you're looking at running services on the host address, -sv is just going to give you the version info on those particular ports. You can also give it -oa, which will save to an output file. This will help you so that you don't have to go back and run the command again to get the same information. If you save it to an output file, you can just have it in your text editor to refer to while you're working. So like I said, Nmap can enumerate many services with scripts, including stuff like SFTP. And we got a question in the chat here. Would it be possible to use multiple addresses? Yes. So this is what I was talking about here. When you run Nmap with the CIDR addressing, you're scanning the entire 10.7.8.0 subnet. So just by running this command, I got reports from 1, 2, 3, 4 different services. There actually might have been more, and I cut it off. So if we look at the details here, it's scanning 10.7.8.1, 10.7.8.3, 10.7.8.4, 10.7.8.5, and on and on, depending on how many machines are running open ports on that particular subnet. So don't be intimidated if you don't know what CIDR means. It means classless interdomain routing, I believe. I'm pretty sure that's what it means. Yeah, classless interdomain routing. So it's just a way that we use for IPv4 addresses to classify different subnets. If you're not familiar with how that works, we can go over the networking stuff in the workshop section. This presentation kind of assumes a basic knowledge of networking. So if you're not quite there yet, completely understand. We can talk about that in the workshop. We got another question. Why would we need port version numbers? Like I said, the port version number is going to give you a good idea of what's running on the service or what's running on that particular machine. So if, for instance, this Proxmox virtual environment REST API 3.0 has any sort of documented exploits, that would be something easy for you to look up using OSINT to try and get into that particular service, to try to interact with that service. So the aggressive scan or the script scan is going to give you the details that you might want to continue on the Capture the Flag challenge. If it doesn't give you the information you want, then you can look at different options. But the version number is just important information that you need when you're performing reconnaissance. Those details are very important when you're performing any sort of attack on a service, trying to capture the flag. So another type of recon you can do is a passive technique like DNS lookup. So DNS stands for Domain Name Service, Domain Name System. Basically what it is a phone book for the internet. It's how our computers know to go to google.com. Domain name systems will link google.com with an IP address, which is how we route to that particular domain. We'll take a quick look at how DNS works in the next couple slides. But DNS records can provide you with useful information about the domains they correlate to. You can get information such as email addresses. You can get information like domain names, who owns the domains, what their phone number is. It's just a good tool to use to look up information about a domain. DNS can also be used for exfiltration or a different type of connection called DNS tunneling, which is where you encapsulate TCP traffic inside of DNS traffic. It's just something to keep in mind when you're examining network traffic. And we'll talk about that a little bit in the network traffic analysis portion of the presentation. So some common tools for DNS lookup would be Dig. Dig is probably the most comprehensive tool to learn when it comes to DNS lookup. But you also have NS lookup, which is on Windows. It's also on Linux, but I just put Windows here because I think it's like the main DNS tool for Windows. You also have Whois, which will give you the Whois information. And then there's several websites online, like the ICANN Whois, and a tool that I found when I was researching for this presentation is called DNS Dumpster. And I'm just going to take a minute to just kind of take a look at DNS Dumpster here, because I just thought it was really cool, because typically when you're doing a DNS scan, you don't get the subdomains either. But if I look up our club site, actually, no, let's not look at the club site. Let's look up mcewen.ca. Remember, this is passive recon, so it's not actually interacting with the McEwen server. This is public information, considered open source information. There's nothing wrong with doing this kind of passive recon on a domain that you do not own. Using Nmap on this domain would be bad. Okay, remember, do not use Nmap or any active scanning tools on domains and services that you do not have written explicit permission to do so. So the cool thing about DNS Dumpster is that it actually enumerates the subdomains for mcewen.ca too. So you get all these interesting subdomains for McEwen, which may give you some interesting information for McEwen. There's really a lot. And I mean, you can do the same thing for like google.com for looking this up. You've got these name servers. That's part of the DNS infrastructure. You got the simple mail transfer protocol.google. And yeah, it's just, for Google, it's going to be a lot. Anyways, I just thought this was a cool tool to kind of go over in the passive recon section, looking up DNS records, DNS Dumpster. Okay, back to the slideshow here. So if you're not sure about DNS or what DNS is, essentially there are 8 steps that your computer will take. Well, 8 steps that will be taken in a lookup of a DNS record. So if you look at this graphic over here, so number 1 is your computer. So you type in, say, google.com into a browser. The query is going to go into the internet and is received by a recursive DNS server. Well, it's actually known as a resolver. So the resolver will then query a DNS root name server. The root name server responds to the resolver with the address of a top-level domain DNS server, like top-level domain being .com, .net, .ca, which stores the information for its domains. So when you're searching for google.com, the request is pointed towards the .com top-level domain. So then the resolver is going to make another request to the top-level domain. The top-level domain then responds with an IP address of the names of the domain's name server, in this case google.com, and then the resolver sends the query to the domain's name server. The IP address for google.com is then returned to the resolver from the name server, and then the resolver responds to your browser with the IP address of the domain requested initially. So that's just kind of a brief rundown of how it works when you go to your browser and type it in. So what is DNS actually transporting? Well, it's going to give you several records, and this is all viewable in the DNS protocol. So you get your A record, which is IPv4 addresses, your quad A record, which is IPv6 addresses, your DNS text records, which is honestly like a bonus field. It's kind of a field for comments. You get your DNS MX, which is your mail records. So which servers that are actually handling mail on that particular domain. Very useful information. It also gives you the CNAME record sometimes, which is the canonical, it stands for canonical name. So if you go to a website, say it's like a short link, it's going to give you the DNS CNAME record is going to give you the true domain name of that short link, if that makes any sense. So there's, like I said, there's several different records that you can view in a DNS request and response, and maybe we can try to look at these in the network traffic analysis section in the workshop later, just so that it's a little bit more clear if you haven't run into DNS before. But if you have, then you'll know that these records provide definitive information about the domain names that you're querying. So like I was saying to the question before, like when you're doing active scanning, any service running could potentially have a vector for more scanning and enumeration, like SMTP, SMB, LDAP, FTP, TFTP, HTTP, IMAP, IRQ, SQL servers, RDP, just to name a few. Okay, any service that's running could potentially have more scanning and reconnaissance that can be done to it. So that's why it's important to know the version information. It can help you narrow down your searching when you're looking at specific services running on specific clients. So another active scanning tool would be like directory enumeration on a website. The one that we chose to kind of show is called Dirbuster. Dirbuster is nice because it has a GUI, so it's really easy to understand what's going on here. Basically, you put in your target URL, you tell it how to work, you tell it how much CPU power you want to give it, and then you give it a list, a word list essentially of what to enumerate. So once again, I just want to say, do not ever run this tool against a domain or computer that you do not have access to. It can lead to some serious problems, and we do not condone any sort of illegal hacking in that matter. Domain enumeration is another very, very loud active scanning technique that is going to get you either banned. First of all, it's going to get you banned from probing their IPs any further. It could potentially lead to you getting disconnected from your ISP, and it could also lead to legal trouble because this can be seen as a violation of law. So when I'm talking about word lists, I like to point towards Kali Linux. Kali comes with these word lists already installed for you to use. So if you want to do domain enumeration, well, Kali is great because it comes with the word list pre-installed. It also comes with so many word lists. These word lists are great for stuff like fuzzing and directory enumeration, password cracking, and on and on and on. But for Active Directory, or for directory enumeration on domains, Dirbuster and Dirb have word lists for you. This is just a screenshot of where they're located in the default Kali install. Obviously, these are available elsewhere. You know, you don't have to have Kali to get these, but it is nice to just have Kali. It's got all these tools there for you. So some other tools for active and passive scanning would be, well, we already mentioned Dirbuster. You got other tools like Shodan, which is would be considered passive reconnaissance. Shodan is an index of all devices that are connected to the internet. You've got Census, which is a paid service. VirusTotal keeps track of virus hashes and malware hashes. So if you have a file that you suspect might be malware, throw it into VirusTotal. It will compare it to hashes against all known malware, and we'll let you know if it has anything. And then also, like we were talking about with DNS lookups, you've got Whois and ICANN Whois. All of these tools are passive in this particular category and are fine to browse and use at your own leisure. Just remember, with active scanning tools, do not use them against any system or service that you do not have written explicit permission to do so. That would be unethical. And then, yeah, so this is just a quick example at the bottom of the slides here for accessing SMTP. Not too important, but it is just a common simple mail. This is, shouldn't it be SMTP? Anyways, simple mail transport protocol is a mailing service that runs on a lot of internal servers. So if it's not secured properly, you can enumerate usernames and passwords on it. And we might have a chance to look at that later in the workshop. Okay, so I'm just moving right along here. I know it's a lot of information. Yeah, we're just going to keep going because we got one more topic to go over here before we get to the workshops. Network traffic analysis. So a lot of categories in Capture the Flag competitions are going to require you to look at network traffic. It's not just its own category. In fact, in the previous two categories, you might be looking at the previous two categories that we went over, you might be looking at network traffic. It's a good skill to develop for dealing with networks in general, like if you're doing any sort of programming that involves networking, or if you're just setting up your home network or an office network. Knowing how to analyze how traffic is flowing can help you troubleshoot problems. So it's just time to go over some basic network ideas. In our previous presentation of this, we just kind of assumed that people had some background knowledge, but we're just going to go over some basic things really quickly. So the way that information is transmitted across the internet is known as the Open Systems Interconnection Model, OSI model. So there's two different versions of this. The 7-layer one is the most common, but there's also a 5-layer one where they combine these session, presentation, application all into one. Basically, you've got your physical layer, which is the wires running between machines. You've got your data link layer, which holds frames. This is the network interface cards on the machine. So this is where you're going to see information about like MAC addresses. You've got the network layer, which is going to give you packets. So the network layer is going to give you information such as the IP source, the IP destination. You've got the transport layer, which is going to be your protocols, TCP or UDP. You've got the session, presentation, and application layer, which I'll just like put into one, which is essentially just the software that is receiving the packets once it's been translated by the network interface card. And if that's all just a lot, I don't blame you. I just tried to summarize networking in like 10 seconds, and it's obviously quite a bit more complicated than that. So what is actually happening is that you get the encapsulation of information is really the most important thing that you need to remember about the OSI model and how things are transported. So as you look here, you can see layer 1 across the wire. You're basically interpreting signals on the wire to get the bits. Those signals and bits are interpreted into a layer 2 frame. Layer 2 frames have all of their own information within each bit field, is what these are known as, of the frame. So you can get information like the is this frame going to have IP information? Is this going to have TCP UDP? Is this going to have HTTP? And then it's going to have information like the MAC addresses of the devices that are sending and receiving. Then at the next level, so you go up from the IP header. If there's an IP header, then you've got within that, the TCP UDP header, which is the next layer. And then within the TCP UDP, you've got the upper layer, which is the next layer. So as you can see, it's like encapsulation. So the data going across the wire is all encapsulated, and that's how we interpret the data coming through. Again, I'm trying to summarize very complex topic in a short period of time. Hopefully that is at least clear enough to have a general idea of what the heck is going on here. So the most popular tool for network traffic analysis is Wireshark. There are other tools out there, and depending on what you're looking at, Wireshark may not be the best tool for you. A lot of capture the flag challenges in the network traffic analysis category are going to involve finding specific information in a PCAP file. What's a PCAP file? Well, it's a packet capture file. And what were we just talking about? Packets. So that's why this is network traffic analysis. So the skills overlap a lot with another category for capture the flags called log analysis. And we're going to take a look at that probably next week, next Monday, when we do a log analysis kind of overview. So what are we looking at in Wireshark? So in Wireshark, you're basically looking at everything that I just talked about. It shows you the encapsulation of the traffic. Okay, so you can capture network traffic on your own computer, on your own network interface, and you'll be able to see this. So you'll be able to see the physical bytes on the wire. You'll be able to see the data link information. You'll be able to see the network information. You'll be able to see the transport layer information, and then the session presentation application layer. So in Wireshark, completely models after the OSI model. It's very easy to go to look at the OSI model and then look at Wireshark and see, oh, this is how this is going on. And you can actually like break down the entire structure of the encapsulation with Wireshark, which is why it's such a cool tool. Yeah, so we'll take another look at this when we get into the workshop presentation. But basically, the display filters are going to be your friend, because when you start to capture on your own interface, or if you're looking at huge packet capture files, you're going to be presented with, tens of thousands, if not more, lines of packets, some of which are going to be relevant, some of which aren't going to be relevant, depending on the challenge that you're looking at or what kind of information you want to find. The display filters in Wireshark have like Boolean operators, and then you typically start with the protocol that you want to filter information from. So like if I wanted to see like TCP information, I would type TCP dot whatever bit field I want to see, and then whether I want it to be equal to something, whether I want to combine two different operators. I mean, you should know how Boolean operators work. And we'll take a look at this, like I said, in the workshop section here. And then, yeah. So I'm just going to post a link to Wireshark in case you don't have it installed already. I should have had this prepared. So I'm just going to throw this into the lounge chat. So if you don't have Wireshark installed, go ahead and head over to that link and get it installed, because we're going to be using it a little bit later in the workshop. So there's definitely other formats that you can be looking at when it comes to network traffic analysis. Some things that we've seen in capture the flag competitions are like byte streams. So you can see stuff like Internet of Things device communication. You can see Bluetooth packets, or like even remote control IR packets we've seen in capture the flags. So these are going to be coming as not packet capture files. And so it can be useful to know how to find information about these and be able to read bit fields is essentially a big skill when it comes to network traffic analysis. And again, just be prepared to use OSINT techniques to find what you're looking for, okay? Like if you open a packet capture file and Wireshark has no idea what to do with it, start checking out the different bit fields to see information that might be useful to decoding it. So like I was saying with like the byte stream, you might end up with a file that are just like a bunch of bytes or like a hex dump. So you're going to need to look at the bytes and match it to some sort of protocol. And then you're going to need to write or find a tool already written to decode and understand it. A lot of the times in Capture the Flags, the name of the challenge might give you some sort of hint as to what is contained within the file, but it might not. So it's just a matter of looking at the details and being able to distinguish details. It's not really a skill that can be taught. It just takes practice. So that's going to be the end of the presentation portion. So I'm just going to stop recording now, and we will take a couple questions and then get into the workshop here, where we're going to just go through 3 different challenges that cover the 3 different topics that we went over tonight.